Okay. So, for example, I drop any random triangle. So no matter like how it's oriented, can be any way, yes? Let's consider exactly your case. So for example, you do have, in your case, let's say you do have that with the angle theta and phi, okay? So let's assume this angle theta, this angle phi, okay? You should see that on the screen right now, because this is the only way I can show you, okay? Let's have a look there. And I put just random sides so that to test the formula, because it works better for you if you know how you can apply it to any random triangle. For example, this way. Let's assume that you have this case, okay? QRP. And you want to figure out how to find, for example, you ask to find sine theta. So sine theta. It's all about the formula. So the formula tells you about sine, just in general ways. How would you define sine theta? You define sine theta through opposite to hype. This is the only way you can define. Opposite to hype. And do you remember the previous questions where you're supposed to label sides? Yeah? Do you remember? No, I mean the previous, really previous one. Yes, you can see that on the screen right now. Oh, you mean you just need to go to the channel. This is the way. Yeah, and you should see that live. Okay? Yeah, you see that. All right, so sine theta, opposite to hype, right? Opposite to hype. That's an idea. Okay. And just remember in the previous one, the previous session, right? And the previous question was about how would you define the sine through the ratios. And I told you that you need to pick up the right formula for that, yeah? So the formula is opposite to hype. Okay, so opposite to hype. And in this case, you just need to label the sides in a proper manner. Okay, so as you can see on this picture, you have R, P, and Q. There are 3 sides. And right now, you just need to define where is hype and where is the opposite to the angle theta. So in your case, side R should be the longest one. But sometimes if you have the picture drawn not to scale, yeah, if it's not to scale, sometimes it's hard to define the longest side. In this case, you just need to have the reference to side opposed to 90 degrees angle. That's an idea. Okay? So side R, in this case, opposed to 90 degrees angle. That's the basics. So that's why it will be hype. What about opposite sides relating to the angle theta? Okay, you just need to track the angle theta and try to find the opposite side that are opposed to the angle theta. Okay, so that's Q, definitely. So you circle sides favorable to you, and you just need to plug in the ratio. So your ratio is opposite to height. So that's why sine of theta, in this case, can be expressed as opposite, so Q over height, which is R. So that's an idea. That's how you need to use trigonometry. But you need to have always to the reference to the formula. So that's why I think it's best way to write sine theta, cosine theta, using the formula again. So this is adjacent over height. And the last one was have the reference to tangent. It's always opposite to adjacent, right? Adjacent. Okay, for example, here is the next question, right? For example, you need to find cos theta. Okay, so cos theta, you have the formula. I just want to circle them as the reference to you. And so please, you can use them as the reference formula, okay? Now in the next question, in the problem, you need to define cos theta, okay? Just let's pick up the right formula from the list. So cos theta in this case just going back to your picture, and right now you need to define, okay, according to the formula, where adjacent side is and where is height. So obviously height stays the same, still R, yeah? So that's why you put R in denominator. And what about the adjacent? Relating to angle theta. So pay attention that you're taking cos from theta. So that's why you taking adjacent side to the angle theta. Let's have a look at the picture. So what do you have there? Still what you see on the screen, still there. So your adjacent side is side P, yeah? Okay. So that's why I just put P and saying, okay, we have P over R, okay? Let's try to consider another triangle that's probably turned a little bit. And what I'm gonna do, I'm going to put another small triangle. Let's say like in case 1F. For example, let's consider 1F case, yeah? Here is your 1F. 1F there. And you have angle theta. You have side 4. You have another angle, let's say phi, right? And the side 7, okay? And 90 degrees angle, always it's right angle there. And tangent theta. Okay, so in this case, so tell me please, how would you define that? How would you define cos theta? You again have a reference of cos to the formula list. So cos theta is always adjacent to height, right? So adjacent in your case, let's mark or label the sides. Where is adjacent? I think it's better to do from the very beginning, at least for you at this stage. So it's better to label. So the first step is just label the sides, okay? Okay. So let's label. So opposed to 90 degrees is always hype, right? Because we're looking at the angle theta, in relation exactly to this angle, we are going to mark sides, okay? Only relating to this angle. So 7 becomes opposite, and 4 becomes adjacent, right? Because adjacent means this is the part of the angle, as you did in the first question, right? Remember? Okay. So now, let's plug into the formula. Cos theta, by definition, is what? Yeah. Cosine theta. Yeah, adjacent over hypotenuse. Okay. In our case, adjacent is marked as 4, right? So that's why it's 4 definitely. But the problem is we don't have hype. So this is the right time to find this, yeah? Okay, so how would we find the hype? So hype is there, and we are not given any value for hype. So this question will be more tricky, so you just need to express hype through other sides. Okay? So hype through other sides is what? Using Pythagoras. Do you remember that? Pythagoras, yeah? Okay, so just try apply. So hype square root of, okay, just put the formula first. Use the values. For a while. Okay, so around 8.1 to 1 dp, okay? Yeah, and we just go back to the formula for cos theta. Now we know hypotenuse, we found that. Okay. You understand. Just it's more, it's more about picking the right formula and trying to see, okay, what do you know? What do you know about which side you know? Okay. So that's why you're just doing by 8.1, and that's going to be the result. And just make sure that your cos and your sine, so that sort of check. For any angle, cos theta is not going to exceed 1, as well as sine. For tangent can be more than 1, no problem. But cos theta and sine theta, they are always less or equal than 1. This is the rule. Okay? So that's an idea. Okay. And so the question is about cos theta, but what if you want to find theta itself? Let's pretend that, okay, we know this value. We divided 4 over square root of 65. And we found out that cos theta in your case, let's pretend that we find cos theta in your case, 4 over 8.1. So we'll get around 0.5 to 1 dp, okay? 1 decimal place. How we can find the angle itself? Because in other questions, yeah, we can do something like try to find the angle, for example. How to find angle itself? Okay. How to find angle itself? We just need to go to calculator and use the -1 button. So -1, this is the power, -1. That means we take an inverse function, right? So inverse function, that means we try, yes, for a given cos value, we're trying to take the angle itself. So that's how we can find the angle. We're taking cos -1 of the value 0.5. Okay. Okay. And if you press this on your button, you'll get cos -1 of 0.5. You'll get 60 degrees. This is about 60 degrees because you round up your value to 1 decimal place. Okay? So that's an idea. Okay. So if it's done with that, so you got the basics, what I would recommend. So I would recommend to leave this as the formula list, yes, and maybe just try a bit more, maybe on the questions about tricks. Let's try here. Sorry, eraser works a little buzzery. Yeah, okay, anyway. Okay, so that's your formula sheet. That's only we can take 2, for example, 2a. Yeah. Okay. So should we take 2a, maybe 2e? Which one is the trickiest one for you? At least it's in, yeah. We can go to 3 if you like, but they are pretty the same level. Two and letter, which one? 2a, 2b, 2c, 2a. Okay, so let's take 2a. So in your case, you have this. So that's your triangle. and you have unknown x, you have a, and you have 70 degrees there. So you need to construct a trig equation connecting the angle with the sides given. Okay, so your sides given x and a, yeah. So how would we operate here? We just need to mark, yes? Before start solving that, we just need to mark. So for example, we can mark relating to the angle always 90 degrees. So that's the angle, 90 degrees. So we try to label the sides. So side A is opposed to 90 degrees. So that's why it's always height, right? So next one, x. X will be in respect to the angle that you're given. Not 90 degrees, yes, but relating to the So that's definitely opposite, right? Okay. We don't need Pythagoras because the question is about construct trigonometric equations. So Trig's equation is what? Connecting always two sides, so two sides, and one angle, right? And an angle. Because Pythagoras, okay, it connects three sides with Trig's. So Trig's ratio or Trig's equation. Let's connect x, y, and 70. Okay, let's have a look at the reference sheet. Right now you have three formulas. You just need to pick up so let's connect that. X, A, and 70. Let's have a look at the formula sheet. So opposite, height, and angle. So in your case, you just pick up where you see opposite and height. That's it. Okay, opposite and height. That's it. That's an idea. So that's why you can, yes, that's pretty easy as you understand. Okay, so let's go there and try to define sine of 70 as the opposite to height. So your opposite is x, your height is a, so that's why just remember that. Okay. Yeah, so that's an idea. So if you've got those basics, so I think you need to work with that problems. Maybe next time we'll discuss it also, okay? Yeah, that's an idea. Okay. If you're well with that, so we can quit the session. That's okay. Or you may stay there, as you like. No problem. Yeah. Yeah. So that were basics, so that's why. It's cool. You should be cool about that. Okay. Yeah. Yeah, thanks. And up to Tuesday, I guess, yeah. Okay, yeah, thanks. So, only love to work hard. Joined. So, only. So we were doing basics in trigonometry. So if you're from GCSE, it might be helpful for you, but if you know those, we can discuss more, harder questions. So, what are program, guys? So if you're doing like insert, probably, I'm not sure about that. But we were discussing trigonometry, we are discussing GCSE questions, sort of that. Okay. So that's an idea. So if you're new here, just explore the source, try to see whether it's proper to you guys. If it's not, probably you can drop any questions related to maths and just any random questions as well. So I'll be pleased to answer everything there. So, okay, that was stream specific design for my students. Okay, so if no questions, I'm just quitting the session and see you next time.